విమానం గాలిలో 5 నిమిషాలు ఎగరగలదని ఇంకా ఎక్కువ సమయం ఎగరగలిగేలా అభివృద్ధి చేయవచ్చని చాటాడు. ఈ సూక్ష్మ విమానం హెలికాప్టర్ మరియు విమానాల నెట్టనిలువుగా ప్రయాణించగలదని తెలియజేశాడు.
My name is Akshay Kaul and I'm a student of JNTU-H Mechanical Engineering Department, and this model, my model's name is, the title of this model is tilt rotor. So it's basically works on a simple mechanism that it is a VTOL type, that is a vertical takeoff and landing type aircraft. Now the mechanism involved here is that it takes off vertically. So it's not like a conventional aircraft that runs on the runway and needs some thrust for that. No, it takes vertically off, and then to change the propulsion, all we need to do is to tilt the rotor in the forward direction to get the forward propulsion. And for the pivotal mechanism here, I've used a simple mechanism, and this mechanism is actually based on super glues and carbon fiber tapes along with the metallic servos. So the servos really work it helps the whole device to move in a specific direction. Now the rolling is that like this in this motion. It is done by varying the speed of both my rotors, and then if I have to move forward, all I have to do is to shift these two by my RC and it will start moving forward. Now if I have to move backward, the same thing, just in the opposite direction. And the yawing motion, that is this motion, is controlled by this. You have to give it a perpendicular planes, like you have to shift it and you get this sort of motion. So this is yawing, and the rolling I already told you, and then I have pitching, which is normally like this. And this is my KK board. This board acts as a gyroscope. Now what a gyroscope is actually is that it controls my flight. Now when I'm controlling it with my RC, if I give a throttle with on one stick, I have to control. I need both of them to rotate on a similar pattern at a similar speed. So that is done by my RC, by my gyroscope, which is the name of this thing is called the KK board. This thing here is the receiver unit, which takes the signals from my RC. And here's my battery. The battery is quite heavy. It's 220 mAh battery, and then the motor itself has a thrust capacity of about 1 kilograms. So the total weight of the aircraft is about 562 grams, including everything. And I have used electronic speed controllers just beneath here. They control the speed of the whole thing. When you're giving it a certain propulsion, this is the thing that takes the input from the battery and gives it to the motor. And I have connected that to the receiver and again to the servo board because it needs to be connected. That's all about my design and overall.
How many minutes it can fly?
In about 5 minutes, some 30 odd seconds.
Can it be extended?
It can be, yes. I have to use either bigger battery or to change the dimensions of the whole thing, get it aerodynamically effective, or again use a bigger device. But then again, I have to compromise the weight on that thing, so I can't do that. So it has to be somewhat optimal. So this is the best I can get. I am more involved towards automobile sector. So aeronautics was something new to me, and I took it as a challenge. So I think I'll try to learn from this. Because
you want to go into R&D?
Absolutely, I would love to work in an R&D department rather than being in the sales or something else. So that should help.
Who has guided you in this project?
Guidance was from almost everyone. Like the most important guide was the internet. You get everything from the internet, and then there were people, the professors from IARE college, and then our own professors. So they have really helped us.
How many feet it can fly?
It can go about 20 feet.
What are its applications?
Again, the applications in defense. So right now for stealth missions, let's say they can use it in defense. You can use it in traffic control. You can use the MAVs everywhere. Most of the application MAV are almost same. You can use them while you're in the, like if you have to survey certain traffic, you have to survey some hostile areas or some areas where you can't go. You can use these sort of things. Now the thing with this is that you really don't need it to give an initial thrust or something. It can carry itself like it's a helicopter, and then it has a better speed, better control. I wouldn't say control completely, but yes, it's much more stabilized, and it uses less devices than a normal quad rotor or any other MAV. So it has a good.
How many times you have tested it?
About I'll be honest with you, I made around 6-7 models before finally I came on to this thing. I used balsa wood first, then I used other frames, I changed my frames. Finally I went with a simple frame, that is I went with a box, and then I somehow sorted the center of mass somewhere at the center, and then I created the platform, the wing platform. And then the most important part was the pivotal mechanism that I need to install for the pitching. So that was really important, and I did that. So it took time a little, but it worked.
How do you see the future of this type of
it's very vast. India is still lacking in this thing. I mean, we are coming up with certain ideas, all right, but this thing is we are getting used to it or getting I mean, people are now knowing about it since we have lot more conferences and symposiums, and people are becoming aware about these things, because if you really search on the net and you get certain idea that people outside at the age of 7, at the age of 13, 14, they already made this thing, and they are participating in various sort of competitions, whereas here we are aware of these things. We are getting to aware of these things when we are about in our college or when we are in school. So that is certain thing where we are lacking, and we hope that the coming generations, like I started it, my juniors, I would really install the knowledge in them about this, and I would really want to share with them. So maybe they can get excited about it, and maybe they should go in a different way and a positive way.
Since how many years it is getting the focus in our country?
I am not exactly sure, but yesterday I attended the conference and they said we are making this since 1970s. So they are developing these designs, but somehow Israel is quite good in MAVs, and if you look into the defense purposes, they really would want to import rather than because the quality outside is definitely better. We are still doing the R&D, which should really help us, and I think now the defense really wants some sort of level from our industry so that we can build up. So it starts from the basic stage, that is, starts from the student self. We people will start it, then only we'll have certain knowledge and we should carry on further.
Since how many years in our country it is getting?
I just said, I heard, I am not sure, it may be 1970. Thanks.
టెక్నీషియన్ మజర్ ఖాన్ తాను రూపొందించిన సూక్ష్మ విమానం విమానాశ్రయాల్లోని బేస్ స్టేషన్లకు ఉపయోగపడుతుందని అంటున్నాడు. ఈ సూక్ష్మ విమానాలలో కొన్ని ప్రత్యేక పరికరాలు అమర్చడం ద్వారా విమానాల గురించిన సమాచారాన్ని, అక్కడ సిబ్బంది సమాచారాన్ని తెలుసుకునే అవకాశం ఉంటుందని తెలియజేశారు.
Think about embedded. This is Mazhar Khan and I'm working for Edgate Technologies. When coming to embedded unmanned air vehicle means, what are the views? We should think from a pilot perspective view. What are required for the base station requirement? So base station need an aerial view, like how pilot is flying the aeroplane or everything. So what we have done is, and also we need to give the locations of the flight. So what we have done is, we have used a sophisticated microcontroller, LPC2148. It's an ARM7 RISC microcontroller. We have embedded a motion sensor to it, which gives the flight rotation direction, like it's taking a right turn or a left turn. And we have a GPS tracker in order to track the location of the flight. And then we are having an embedded camera for a view, pilot view. It will be fixed on a cockpit, where we are going to fix it on this flight module, and we are going to view the aerial view of the flight. So how it is transmitted? A hard code, embedded code has been written on LPC2148, which transmits the latitude, longitude positions and the accelerometer, like tilt sensor directions, right or left, through wirelessly via a Zigbee, working on a 2.4 megahertz, and it is received at a receiver base station. We have a receiver module. This is a receiver module which receives these two information and process it and display it on a display system, which we have done for a base ground stuff.
How many minutes it can fly?
It can fly approximately 15 minutes. Yeah, my battery backup is a 2200 mAh battery, and it can be operated for 15 minutes approximately.
How much altitude it can achieve?
Sir?
How much altitude it can achieve?
They have designed as 100 meter. We have tested for that only. But when you cross 50 meter limits, due to glitches and non-reception of signal, we have a loss of control on this flight.
What are its applications?
It can be it's very useful. It is very useful, and it's coming at natural calamity conditions where we can send our pilots or refugees, so that we can go there. Real persons can't go when it's still in progress, like natural calamities are going in progress. We can't go with plane, so we can use this type of device so that we can view and monitor the other locations, and we can send whenever the condition crisis is coming down, we can send a refuge center. So this flight can be used for maneuvering purpose for that.
JNTU వైస్ ఛాన్సలర్ ప్రొఫెసర్ రామేశ్వరరావు KAB టెలివిజన్తో మాట్లాడారు. సూక్ష్మ విమానాల ప్రదర్శన కోసం మరో వర్క్షాప్ను త్వరలోనే నిర్వహించబోతున్నామని వెల్లడించారు. తక్కువ సమయం ఉండడం వల్ల విదేశీ విద్యార్థులు ఈ ప్రదర్శనకు హాజరు కాలేకపోయారని ఆయన అన్నారు.
JNTU-H is conducting this international conference on micro air vehicles. This is first of its kind, in our country and also at JNTU-H. We have experts coming for this conference from various parts of our country. They have spoken on specialized topics like guidance, navigation, controls, different types of applications of MAVs like security, reconnaissance, pollution hazards, monitoring the environment. About 67 papers have been presented, and the experts also delivered a keynote address. A lot of interest has been shown both by the academic bodies and also by the student community, and we have had a very fruitful exchange of views. This conference will definitely help in disseminating specialized information in the field of MAVs, which can be used